Long before iron nails became common and centuries before engineered trusses, Viking builders solved a problem that still challenges modern carpenters: how to keep a heavy roof from creeping, twisting or groaning under wind, snow load and seasonal wood movement. Archaeological remains across Scandinavia show roofs that held their alignment for generations without metal fasteners, without rigid joints, and without audible movement during storms. This was not luck or overbuilding. It was a precise roof log locking method designed to remain silent, flexible, and immovable at the same time. Once understood, it explains why Viking halls survived brutal winters without structural failure. Why Viking roofs had to remain silent as well as stable. Noise was not a minor concern. In longhouses, sound carried through timber frames at night, disturbing sleep and signalling weakness in the structure. Creaking roofs also indicated stress points that would worsen with time. More critically, Viking roofs carried massive loads of turf, sod or wooden shingles saturated with rain or snow. Any lateral movement could cascade into collapse. Vikings needed a roof that settled once and never shifted again. So, let's talk about how the roof log system actually replaced those old rigid fastenings. Instead of, fixing rafters tightly to wall plates, the Vikings used this clever gravity-locked roof log system. The main roof beams were laid into carved saddles along the wall logs. And, rather than being cut straight across, these beams were shaped with these shallow, opposing curves. Now, this design allowed the beam to drop into place under its own weight. Once seated, the log simply could not slide sideways without lifting itself first, which, gravity just prevented from happening. And the heavier the roof became, the tighter that lock held everything together. Here's why the carved saddle was actually more important than the beam itself. The saddle joint was really the heart of the system. Viking builders would carve the receiving notch just a bit deeper at the centre than at the edges, making the whole system work brilliantly. When the roof beam settled, its weight forced it into the lowest point of the saddle. Seasonal expansion and contraction occurred upward and inward, never outward. This eliminated the sideways creep that plagues flat-seated beams. The joint allowed vertical movement without horizontal drift, which is why roofs stayed aligned for decades. How roof weight was used as a stabilizing force. Modern construction often tries to reduce roof weight. Vikings did the opposite. Turf roofs, sod layers, and thick wooden coverings added deliberate mass. This weight pressed beams firmly into their saddles, dampening vibration and wind movement. During storms, the roof did not fight the wind. It resisted through mass and friction. The system became more stable over time as the structure settled. So, why did wood-on-wood contact prevent noise? Well, metal fasteners tend to transmit sound, whereas wood joints, on the other hand, absorb it. The Viking roof log trick actually relied entirely on wood-to-wood contact, often with a thin layer of birch bark or tarred fibre placed right between the mating surfaces. This acted as a natural sound damper while also shedding moisture. As a result, roofs remained quiet even under shifting loads. Silence was really a byproduct of correct geometry, not added insulation. So, how did builders prevent rotational twist in roof logs? One danger of round roof logs is rotation, of course. Vikings prevented this by flattening only the bottom face of the beam where it contacted the saddle, leaving the rest of the log intact. This flat surface locked the beam's orientation while preserving its strength. The beam could move slightly up or down as walls settled, but it could not roll. This detail appears consistently in excavated roof remains and is, honestly, one of the clearest signatures of deliberate design. Now, let's consider how this system adapted to seasonal wood movement. Scandinavian climates forced timber to swell in summer and shrink in winter. Rigid joints, well, they cracked under this stress. The Viking roof log system allowed micro-movement without loosening. Walls could settle, beams could compress, and the roof adjusted silently. Because nothing was nailed tight, nothing tore apart. The structure aged gracefully instead of fighting physics. So, how can this method be applied in practical modern building? Well, this principle is actually directly usable today in things like cabins, sheds, and off-grid structures. Instead of fastening roof beams rigidly to wall plates, builders can carve shallow saddles that allow beams to seat under gravity. The key steps are, shaping the notch deeper at the centre, flattening the beam's contact surface, and allowing the roof covering to add stabilising weight. Metal fasteners can still be used sparingly to prevent uplift, but really lateral stability should come from geometry, not force. Why did this trick disappear from common practice? Well, industrial lumber and standardized fasteners shifted construction towards speed rather than longevity. Square beams replaced round logs. Nails replaced carving skill. The knowledge faded not because it failed, but because it demanded patience and understanding. Yet the Viking method solved a problem modern builders still patch with brackets and reinforcements. Why the silent roof mattered beyond structure. A quiet, unmoving roof meant safety, warmth and confidence. In a Viking household, structural failure was catastrophic. This roof log trick, you see, represented trust in craft rather than materials. It required no replacement parts, no tightening, and really no maintenance beyond just basic care. It worked because it aligned with gravity and wood behaviour instead of, resisting them. Understanding this system, well, it changes how Viking architecture should be viewed. These were not rough shelters. They were finely tuned machines, built from trees and earth, designed to last in one of the harshest environments on the continent. If this exploration of Viking structural mastery added depth to your understanding of early engineering, support in the beginning by subscribing, sharing this episode, and helping ensure that precise historical knowledge continues to be passed on.